Hello everybody. It's Mr. Pouts here for section 2.5 part A. So we're dividing section 2.5 into two different days or two different sections because there's a lot that goes into it, especially since it's the beginning of these things that we call proofs. So here's kind of what we're going to do today. We're going to skip the warm-up because we'll do that in class. We're going to talk about a whole bunch of properties, and these are a whole bunch of properties that you're going to be using throughout this whole geometry course. So get familiar with them and the understanding of them. Then we're going to be talking about how we can use those properties to support statements, and that kind of leads into this intro to proofs as well. We won't have practice time right now, but we'll have some examples to go through. So the goal that you should take your goal sheet out and write down is connect reasoning in geometry or algebra and geometry. Okay. While you're writing that down, this picture in the background is pretty sweet, isn't it? That was I actually took that last year when I went to Mexico. I was scuba diving, came in close encounter with that big shark, and I got a great picture of it. I'm just kidding. I would never do that. That would scare the bejeebers out of me. But anyway, it's a pretty sweet picture, isn't it? So we're going to go on. We're going to start talking about all these properties. So the first group of properties that we're going to talk about are the properties of equality. We're also going to have properties of congruence. And I think these are listed in your notes for you. But make sure you highlight them. Make sure you kind of look at them, see how I explain them, and take them all in. So there's a whole bunch of them. So the properties of equality are things that you've actually used to solve equations. So we have A, B, and C are going to be our real numbers that we're working with here. All right, so the addition property equality basically says if you have A equals B, you can add anything to both sides as long as it's the same thing. So you could do A plus C equals B plus C. As long as you do the same thing to both sides, it's legal. That's called the addition property equality. All right, subtraction property equality is very similar. So we're saying if A equals B again, then we're going to make these into conditional statements since that's what we're practicing. Then A plus, actually no, we're not using plus, this is subtraction. So then A minus C equals B minus C. Same thing, you can subtract something from both sides, or from one side of the equation as long as you subtract it from the other side to keep it balanced. All right, same thing here. If A equals B, then you can multiply. You can do AC equals BC. Multiply both sides by C, it's legal. And lastly, if for division, if A equals B, then same thing, we can do A divided by C equals B divided by C. That's assuming that C is not 0. All right, now I've got a couple new properties that maybe they would seem obvious to you, but we haven't really stated them. We haven't really used them for exactly what they are, but we'll be using them today. So the reflexive property of equality simply states that A, or any variable or any number, is equal to itself. Okay, reflexive property says that a number is equal to itself, or a value of some sort is equal to itself. It seems like common sense, but we can state that. All right. Symmetric property, you might think of symmetry, and maybe the reflection symmetry is more what we would think of here. So if A equals B, then we can reflect it over and say then B equals A. Okay? That's the symmetric property. The last property of equality, actually I guess we have two more. The transitive property would be if A equals B and B equals C, then A equals C. And you'll notice that's very similar to one of the laws we talked about in section 2.4. So we look back, it's very similar to one of those. The last property of equality is the substitution property. So basically, if you have A equals B, like we've been having, then you can substitute B for A in any expression or equation. So we'll say then B can replace A. And it could be vice versa too. You can replace A with B. But that's a substitution property of equality. It'll keep the two halves of the equation still equal to each other. All right, those are all our properties of equality. We have 1, 2, 3, 4, 5, 6, 7, 8 of them. We're going to talk about the properties of congruence soon too. But there's one more property. I think this is how they're all listed in your notes. There's one more property which is worth reviewing because you can use this one as well. This would technically be a property of equality as well. It says you can use multiplication to distribute A, or just a term outside of the parentheses, to each term of the sum or difference inside the parentheses. So it works for both addition and subtraction. And I think you've done this plenty before, but you can distribute the A to the B and the A to the C, and you get AB plus AC. Or same thing for subtraction, you get AB minus AC. And that's the distributive property. Okay? These are all properties that we'll be able to use when we do proofs. So let's just name a few of them. So oftentimes when you're doing a proof, you're going to be given a given and a conclusion. And it's your job to use reasoning to get from the given, what you're starting with, to the conclusion. I'm going to give you some basic ones here. And these are just ones that we're going to use properties of equality for. And they'll just be one-steppers. Sometimes you'll get proofs that could be up to 10 steps. We don't have a lot of those in this course, but at some point in your life you might get to that. So let's start with number one. What property of equality would be a reason that for getting from 6x plus 2 equals 12 to 6x equals 10? Well, my guess is you'd subtract both sides, 2 from both sides, so that'd be the subtraction. Let's say property of equality, POE. All right, number 2. So we have measure of angle 1 and measure of angle 2 is 90 degrees. And then we have measure of angle 1 is equal to 90 degrees minus the measure of angle 2. So it looks like we're subtracting the measure of angle 2 from both sides here. And that would be, again, the subtraction property of equality. So I'm going to take this whole thing and I'm going to own it, because I think that would be the same one right here. All right, going downwards. All right, we have x, number 3, x equals the measure of angle C. Now it says 2x equals the measure of angle C plus x. So, at first glance, you might think we're multiplying both sides by 2, but if you look at the right side, there's no 2 there. So you added an x. So really, you are adding an x to both sides. So this would be the addition property of equality. Because if you add x to x, that becomes 2x. So that's where it comes out. That's the addition property of equality. Now look at number 4. It says q minus x equals r. And 4 times q minus x equals 4 times r. Now if you look, this conclusion looks like you'd use the distributive property. But our goal is to try and get from the given to the conclusion. So to get from the given to the conclusion, the one step that we did was multiply both sides by 4. So that would be the multiplication property of equality. All right. So going to number 5 and 6 here. Number 5, we got a lot of angles here. It says we're given that the measure of angle Q minus the measure of angle R equals 90 degrees. and the measure of angle Q equals 4 times the measure of angle R. And we're concluding that the measure 4 times the measure of angle R minus the measure of angle R equals 90. So it looks like to me that we replace the 4 measure of angle R for the measure of angle Q because it says they're equal. So that would be substitution. Let's do substitution. Oops. That says substitution. You get the point. I missed a U and a T in there. That's the substitution property of equality. Number 6, it says CD is equal to EF minus 2CD. Then we concluded that 3CD equals AF. Remember, when we have just 2 letters, that looks like it's going to be a line, but it's actually would be the distance of the line without anything on top. That's the distance of the line CD and the distance of line AF. But to me, it looks like you added 2CD to both sides to get this AF by itself. And then you get 3CD over there. So that would be the addition. Property of equality. And I think I have 2 more here. So number 7, 5 times, oh, right there, it looks like this should be the distributive property is my guess. And you get 5 times y minus 5 times x equals 20, so that's the distributive. And the number 8, the measure of angle AOX equals 2 times the measure of angle XOB. And 2 times the measure of angle XOB equals 140. So we can conclude that the measure of angle AOX is equal to 140. And again, these should be degrees, just to be clear here. It looks like we did if A equals B and B equals C, then A equals C. So that would be the transitive property. Property of equality. Okay, so this whole list of properties here are key. We're going to be using those lots, especially to finish up this chapter. We'll come back. We'll be using those in other chapters as well, but these are the ones that we're going to use for proving things. Now, there's also 3 properties of congruence. And we've talked about how equality and congruence are a little bit different. Equality deals with an actual number, like the degree of an angle, the degrees of an angle, or the distance of a line, whereas congruence just is talking about the line itself or the angle itself being the same, not putting a number to it. So the first one, and these are very similar to before, we have the reflexive property of congruence. Reflexive, if we're dealing with segments, we can say that segment AB is congruent. I'm sorry, that's not how you write congruent. It would be an equal sign, with the little squiggly line on top, is congruent to AB, segment AB. For angles, we just have an angle, so we'll say, and it wouldn't be the measure of an angle, it's just the angle itself. So we'll say angle A is congruent to angle A. Reflexive just means it's congruent or equal to itself. All right, now the symmetric property of congruence says that if AB so segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Same thing goes for angles. If angle A is congruent to angle B, you can probably guess that then angle B is congruent to angle A. So it's kind of the symmetric, it's thinking of reflection symmetry there, reflecting it. The last one here then is the transitive, so we're doing transitive again. This one's a little bit longer, so we're going to say for our segments, we'll say if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB, what is that congruent to? We know it's congruent to CD, but it's also congruent to EF, segment EF. So it's that if A equals B and if B equals C, only we're using congruence here, then A is congruent to C. Same thing works for angles. So if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is also congruent to angle C. That is our transitive property of congruence. So let's look at some examples here for picking out what the correct statement would be. Match the property to the appropriate statement. So we got to decide between equality and congruence, reflexive, symmetric, and transitive. So let's look at number 9 here. It says segment RT is congruent to segment RT. Well, that's a congruence one, and it looks like reflexive, so we're going to go with B. All right, if angle YER is congruent to angle IOP and angle IOP is congruent to angle WXZ, then, okay, so that would be congruence, and that's a transitive, so it would be F. So we got another congruence one here. If segment PQ is congruent to segment MN, then MN is congruent to PQ, so that would be the symmetric property of congruence. So that's D. All right, we've just got the equality ones left. So if XT is equal to YZ and YZ is equal to UP, then XT is congruent to UP. That's transitive of congruence, so we got E. 13, measure of angle 1 is equal to measure of angle 2. Or sorry, measure of angle 1 is equal to measure of angle 1. That's reflexive of equality. And that leaves us with if the measure of angle RQS is equal to the measure of angle TEF, then you can reverse it, and that would be the symmetric property of equality. Okay, so that's all the properties and what they mean. Now we're going to just quickly here talk about proofs. And I want to finish this pretty quick. So how we can use them in a proof. So a proof is a convincing argument that uses deductive reasoning. So really, when you're writing proofs, you are making an argument, you are stating your case. This is like the very first steps to becoming a lawyer, because you're giving reasoning and you're giving proof for everything that you are doing to get to your final conclusion. So a proof logically shows why a conjecture is true. So you're explaining the why. You're not just giving your statements. Someone who's arguing and just giving statements and no reason doesn't work. It doesn't give you any validity. A two-column proof lists each statement on the left and the justification or the reasoning for each statement on the right. Note the steps must follow logically from the steps before it. So below is a sample setup of a proof. So it has to kind of follow before unless it's just listing things you know right away, things that are given. Otherwise, it kind of should follow a logical sequence. So I'm going to show you how to do one of those, and we're going to just use algebra for right now. This is kind of how it's set up. If you're given a given, you're given something to prove. A lot of times we'll be given a picture in geometry. So you always start with the given statement. The first statement is usually the given statement. You can list that. You can list what's stated, and your reason is it's given. Your last statement will always be what you want to prove. So that would be, or the conclusion. So we're going to have that, and then whatever your reasoning is at the end. Everything in between is how you get from that first thing to the last thing. Sometimes there'll be one step. Sometimes there'll be no steps between. Sometimes there'll be 5 steps between. Okay, we're going to start with some basic ones here. And this two-column proof is probably the most common one that you'll see, probably the most common one you'll use, and it's probably the easiest one type of proof to use as well. So let's do one right here. Let's cover up this bottom part. We don't need to see that at all. So what we're given is that x divided by 3 plus 4 is equal to 1. We're trying to prove that x, looks like we're going to need another thing here, I think. Let's just start with x over 3 plus 4 equals 1. That's given. So that's our reasoning for that one. Next up I'm going to do is, well, you probably should know this. You're going to subtract 4 from both sides. So you end up with x over 3 equals, subtract 4 from there, you get negative 3. That would be the subtraction property of equality. That's our reasoning. That's why we can do that. The next step, I think, to isolate the x would be to multiply both sides by 3. So you're going to end up with x equals -9. And that would be the multiplication property of equality. And actually, that's it. We're done. That's our last statement. That's what we're trying to prove. We had our given, we had our proof, and I always put a smiley face at the end because we proved something there. We just proved that x does equal 9 given what we had. And we gave our reasoning. We stated our case. So what I'd like you to try to do on your own here is do the second example. It's going to be a few more steps, I believe, but I think you can get there, and I think you can figure out the reasoning for each step that you do. So essentially, you have to show your work for how to get to x equals 7. All right, go ahead and do that. All right, so here's how I would do it. I'd always start with the given. 2 times x minus 3 equals 8. And that is given. That's our reason. We don't have to give any other reason than that. And it looks like we're going to finish with x equals 7. I'm not going to write that down there because I think there's 5 steps, but I'm going to hold off right now. So the first thing I'm going to do, and there's different ways of doing this. You can do a couple different ways, but I'm going to distribute first. So I'm going to have 2x minus 6 equals 8. And that's the distributed property. All right, then I have a two-step equation, so I'm going to add 6 to both sides. So I'll have 2x by itself here, so 14. That would be the addition property of equality. Whoops. Then I have to divide both sides by 2. So I'd end up getting x equals 7. That would be the division property of equality. Now you might think that you're done because you got x equals 7, but we're trying to prove that 7 equals x. So there's one more step that we have to do. How can we flip around to get 7 equals x? Let's look back. Which property would that be? I think that would be right here. If a equals b, then you can flip it around and say b equals a. So that's the symmetric property of equality. So our last step here would be the symmetric property of equality. I know that one step, but you have to give reasoning if you want to figure out that 7 equals x instead of x equals 7. All right, so that would be the last proof here. The rest of it we're going to do in class tomorrow. So I hope you learned something here. Any questions that you have, you should bring to class. Bring to class, please. Based on this goal of connecting reasoning and algebra and geometry, especially dealing with these properties. We're going to do a few more proofs next time. All right, so hope you have a good rest of your day, and we'll see ya.